Good afternoon, everyone. My name is Puneet Kumar, and I represent EY Parthenon. First of all, I think we are seeing some thin audience in the crowd because we have just finished lunch. But I hope people who are just finishing up will also join us. So again, welcome all of you to this post-lunch session. We have 5 esteemed doctors on the panel, and I'm feeling a bit odd out. I'm not a doctor, and this is like a first time for me. And I look forward to their thoughts and guidance on this very important topic. The topic, as Praveen said, is accelerating innovation and R&D in petrochemical industry. Petrochemical industry, how it has been growing over the years in India specifically, how India has become one of the major petrochemical producer in the world and also the consumer, is the foregone conclusion. It will continue to grow. What we have seen is that all parts of petrochemicals, whether we are talking about commodity petrochemicals, specialty petrochemicals, everywhere we have seen large-scale investments. But when we look at the other side, which I would like to put it back versus my focus areas, have we seen a similar investments in R&D? Some of the numbers which I was just crunching through yesterday, the percentages are like 0.3, 0.4% of the net revenue, which is at least 3-4 times lower than the global average. So why am I stressing upon this point is that R&D we know is the bedrock for the future growth. So if we invest more in R&D, we make an environment which helps you to grow and which actually makes the industry self-sustainable and it can meet the future requirements. What we have also seen on the policy front, Government of India, Ministry of Chemical and Fertilizer have taken multiple initiatives, whether it is around making up PCPIRs, talking about plastic parks, various initiatives about how you give grants. But end of the day, when we take a step back and try to see that, okay, things have definitely improved, things have been improving, but when we look back and see that the session topic is how to accelerate. How do we look in terms of our policy issues? How do we look in terms of our taxation, investments? How do we look in terms of how do we actually look at incentivizing R&D scientists, incentivizing R&D program? And of course, how do we bring in collaboration? What can we do in terms of bringing people, not just in India, but experts from across the globe together? That's the topic which we are talking about. And I will start the topic with this discussion with Dr. Krishnan. Dr. Krishnan, of course, has been a senior member. And Dr. Krishnan, I think as the senior most person on the dais and of course, looking at your wealth of experience, there were a few things in my mind and actually I just wanted to start talking about those. See, R&D innovation, how do you see these R&D innovation policy environment shaping up? What has happened? Well, you have seen it as a part of your organization and the industry in general. How do you see this market growing, evolving, and taking in the future?
As you rightly told, R&D, the money involved in the R&D or the budget is only 0.3%, which is very much on the lower side. Unless we increase to 2 to 3%, nothing can happen. And whatever we do, it's very, very nominal. We are not able to do substantial. If you miss the time, then definitely we will lose it. And India is having a huge scientific manpower and young populations. Therefore, definitely we should make use of the opportunity by means of increasing the investment, maybe 2 to 3%. That is one thing. And another thing is that when you concentrate on the research, the focus should be on the applied research rather than that fundamental research. For that, you should know what the industry needs, what the country needs. If you see that, we import a lot of chemicals from other countries, and Government of India has also identified over 500 chemicals has to be developed indigenously. They have already identified. Therefore, we should focus on that so that we can substantially save the foreign currency, as well as we can maintain, as well as we can become a self-reliant. That is one thing. And other than that, the Government of India, they made a lot of policies to make it a very innovations very effective. As you told that the national policy on petrochemicals, it was started in 2007. wherein they decided to have a PCPR to be established, and already 3 is in working conditions. And then they also decided to establish a center of excellence. So far 13 center of excellence has been established, and we are having, CIPET is having 3 center of excellence. Even the first one we got it. It is on the, it's known as the green center of excellence on the green transportations, where we where we developed for the automobile components using natural fiber reinforced components. That part we did it. And the other things which we also got one more center of excellence is on the sustainable materials, especially the green polymeric materials. That COE also we got it. And the third is on the 3D printing, mainly on the biomedical devices. The last COE was given is on the toys, because India, if you see that lot of toys are being imported, and therefore we need to develop our own toys, and then therefore they established the COE on the toys, and to help them also CIPET has established toy testing facilities in Aurangabad, so that most of the toys can be tested. For that we have done it. And then to further make the innovations effective, the national award was established, and they started in the year 2011, and so far we have given 12 national awards, and then recently they renamed it into PRC, that is Petrochemical Research Innovations Commendations, and CIPET is organizing all these awards. And only last week the PRC, the first PRC was over, and we hope that soon we will be awarding. The purpose of giving such awards is that to help the youngsters as well as to know the industries that what has been developed, and this is what the government of India, in my ministry, especially the DCPC, Department of Chemicals, Petrochemicals, is doing it. Apart from that, for doing any innovations, you need a very good analytical equipments, and these are all very expensive, and then establishing is very, very difficult and it's expensive. Therefore, the government of India has also made it one thing known as ISTEM. ISTEM means Indian Science, Technology, Engineering Facilities Map. It is in the Indian Institute of Portal. Therefore, any institute who got very sophisticated instruments, they can register it, so that any researcher who wants to make use of such facilities, they can approach the portal, the Indian Institute of Portal, and pay the nominal fees and then do it. So that the government of India money is also saved, rather establishing the same equipments in each and every center. We have also put our facilities, and then CIPET initially, if you know that, we started with a training institute, and today we have come with the R&D centers also we have established. 3 R&D centers we have established. If you happen to get time, please visit them. We are having the world-class R&D infrastructures, one in Bhubaneswar, where they work on the polymetric materials, and in Chennai we do on the design concepts, and in Bengaluru we do both on design and then on the R&D. This is what we do that. And CIPET, apart from that, we also regularly conduct international conference, so that the research scholars, they come and exchange their ideas, and you also get to know that. The next APM, we planned it in the month of February on 14th to 16th. Please make use of it, come. These are the various initiatives done by the Government of India as well as by the CIPET.
Thank you, Dr. Krishnan. This was a good summary of how government is fostering various policies, fostering the R&D environment, and of course how CIPET has actually gone about it. I think we talked a bit about the policy front. Just to take this discussion forward, I would like to ask Dr. Gurmeet about, and since he's the only one from the industry, that how is industry academia linkages? What can we do better?
Yeah, thanks, Puneet. Industry and academics both have got their own perspective to look at what is going around. For example, I belong to industry, and by now my team has got around 150 patents and only 25 publications. If we talk about somebody from academics, that number will be simply reversed. It will be all publications. Through publications, generally the academics, they try to focus on the basic research. But now our country is also at the cusp of a revolution where we are becoming more and more Atmanirbhar. And but we have to maintain this competitive edge also in the coming time, and that can only be done through innovation, for which the robust R&D is required. But for that R&D, both the academics and industry will need to work together and move ahead. I have noted on some points where I can have that discussion taken forward. These gaps are very much essential to fill because of the theoretical knowledge which is offered by the academics and the practical knowledge which is offered, which it belongs to the industry people. So if we work together, definitely any problem, any big challenge can be resolved. And if we talk about the current landscape in India, we have got a large number of institutes. Few of colleagues are sitting on the dais also. Those institutes, the talent what is there is mostly underutilized if we talk about translating them into technologies, making a product, go-to-market product for which we can find readily available customers. And the gaps are because of restrictions to knowledge transfer, access to the cutting-edge research, and which slows down the total translation of research findings into commercially viable solutions. So some idea may be there with a professor sitting in chemical engineering department in IIT Delhi, but how we can translate, say for example, jointly with us and push a product to the market. And if we talk about the different benefits of industry academic linkages, first simple is the enhanced R&D. We can tackle much more complex challenges. We can lead to the breakthroughs in petrochemical like catalyst, process optimization, etc. The knowledge exchange, which at present is very negligible, that is paramount to any further development and development of cutting edge technologies. And it will allow the transfer of technology and enables practical solutions to real world challenges. So that is very important because end of the day, if we develop something, it has to find some customer or customer has to find the right product. Talent development is also very much essential. Like at Indian Oil, I might have trained more than 25-30 BTechs and MSc students, and all of we try to make them aware what is going around in industry and what type of knowledge base they require, so that once they step out of their academics, they are ready to be absorbed by industry, and most of them have been absorbed by industry in India and many of them abroad also. And if we talk about the technology transfer, next point is it is a gain situation for both academics and industry. Academics gain access to industry-specific programs and resources, while we also benefit from quicker access to innovative technologies and expertise. Generally, what happens at academics is at the initial phase of any cutting-edge research. But if we are sitting in industry, we look at the same basic research from a different perspective and add value to it and maybe help to launch a commercial product. Innovation ecosystem is a very important thing. Strong linkages in India is required at present to have a vibrant innovation ecosystem where we not only attract the talent but we investment as well, fostering a culture of continuous improvement. Now, as my previous speaker was sharing that they launched those national awards, and such awards are actually very good incentives for people both from industry, academics, and I'm happy to share I won 3 of them. So, but then everything is not so rosy. We have won challenges and opportunities also. Academics and industries, they have got entirely different culture. The main concern which we have to address before we jump into any collaboration is the IP protection. So clear agreements have to be there. It is a very touchy subject. Cultural differences regarding the priorities and work cultures, incentivizing collaborations, that has to be taken by both industry academics and from the government level as well. And if Puneet, can I give some recommendations?
Of course, go ahead.
Yeah, so the way I see on my personal level is that the joint research projects have to be identified with utmost care and diligence. While industry is ready to provide the funding, academics have to contribute through expertise and analytical rigor. And industry wants the product to be delivered tomorrow, and we don't have the patience to wait for longer horizons. Joint research centers are also one of the things where industry and academics both can work. And already there are some models. We are also investing in some research centers in say, IIT Mumbai also, where the research on energy is taking place. Faculty exchange programs, like I can, if I like, I can go and teach some subjects in some academic institutions. Same way, some faculties from academics can come down to some industries and have that exposure, so that understanding and the cultural differences can be capped, and the students who come out of from academics will be ready to be absorbed in the industry and to deliver from the day one. Technology transfer offices is also very critical. IIT Delhi have started one through FIDT, so where they undertake all that technology transfer from academics from that institute to the industry. So such offices are required everywhere. And yes, industry academic linkages are the bedrock of innovation, and they help us foster a vibrant ecosystem where knowledge has to flow freely. And for petrochemical, this is more critical because most of the technologies what we are implementing in India are all imported, and if we have to make us a self-reliant country, we will have to have these innovations done jointly so that we can deliver them expeditiously. Thanks.
Thank you, Gurmeet. I think you have put in all the necessary things. We need to create an ecosystem. Industry and academia need to work together, not just one-to-one, but many-to-one or many-to-many models. You have to talk about in terms of technology transfer, how it happens. IP is very, very important. And since most of the institutes here are government institutes, it would be good to have like suggested models coming in some form. That would be good to have. Of course, collaboration in terms of joint research projects, how do you take it abroad, how do you bring external experts, all this is very valuable. I think the important thing which you said in the middle somewhere is that how do you incentivize both the parties? And with that perspective, I'll just take the discussion forward to Dr. Kamble. Dr. Kamble, my question to you in terms of this discussion is that how do you see these grants, incentives which are being given to the R&D sector? What can we do better there? How can we accelerate? Whether these grants are good enough or it has to be enhanced, the process has to be done, or what do you think could be done better versus comparable global institutes? Over to you, sir.
Thank you, Puneet. This is actually a very important question. Actually, if you say that in petrochemical industry, 90% technologies are imported, okay? And now they are thinking diversification and development of new product and processes. So maybe there are a lot of differences. As you know that there is a gap between industry, academia, academic institute, and government policies. So basically, we should have first minimize the difference between these three institutes. We should come together and formalize the guideline, how to run the project basically. Because what I have seen many times, academic institute, they are doing basic work and project may be running a few months, after that, that project is gone. And sometimes industry interested to scale up the, maybe from idea to commercialize that product or processes. But there is a lot of differences in the policy as well as the run and the way academic institute and industries are running the project. So first of all, if you identify proper area on what kind of product and process we need to be work out, that is first thing. And second important thing that we should have a state-of-art pilot plant facility, because sometimes we are doing R&D in lab scale, but we don't have feasibility study, like pilot scale facility, so that we can validate whatever the product and processes. And third one is government norms. That is also important. So government policy is also important for this. And rightly, Puneet, Gurmeet Singh as well as previous speaker identified that we require good human power, because presently because of IT, digitalization, most of the good students are changing their field. Nobody was interested in core R&D, core chemical science, or maybe physical or mathematics. So everybody is interested in digital world, and nobody was interested. So we should have a good team, basically a human research development for the chemistry, basic research as well as for applied work. And that is, I think, major challenge for us because of digitalization. And now, yes, industries are interested, even government policies like the PLI scheme is there. So basically, we are also IIT, they are taking basic research, basic work, or maybe you can say that which is not applied to industry, but they are doing some modeling or some lab scale work. But like CSIR lab, we are working to provide end-to-end solutions, starting from raw material, selection of road, then optimization of process parameters, scale up of the process, then see the feasibility of the process, and last to support industry up to commercialization. So such kind of work is required for industry. But funding, now some of the petrochemical industries are giving funding. There is a good opportunity to collaborate and develop a process and do the diversification. For example, petrochemical industry, now instead of petrol and diesel, they are thinking whether we can produce some good chemicals which has a good value. Because now India, we are importing a lot of chemical, and government, there is intention to Atmanirbhar Bharat, Make in India program is there. For example, we are importing like 135,000 tons per annum bisphenol A, which is bisphenol A we can produce from phenol and acetone, and that raw material is available from petrochemical industry. Similarly, salicylic acid is there, ibuprofen, which for ibuprofen, again, IBP is a raw material, and IBP we can produce from C7 fraction, like basically toluene, and they have propylene. And so, if you use that raw material properly, and if you produce important intermediate or chemical which is required for agrochemical, maybe pharma intermediate, dyes, textile, many applications are there. Now government of India has listed maybe 500 chemicals. Out of that, I know that 51 chemicals are important, and we have got a couple of projects on that, and we are working how to develop sustainable chemical from petrochemical feedstock. And we are thankful to petrochemical industry. We have got a couple of projects, and we are working conversion of this particular steam into final product. And now we are up to commercial stage, and in the coming year, maybe around 25 kg per annum pilot plant will be ready for the production of specialty chemical. So if you join hand to hand, I think success will be there, and we can achieve the target. But we should have a roadmap. What kind of work need to be done, and what is the government policy need to be established. So that is my comment. Thank you.
Thank you, Dr. Kamble. I think this was a very vivid description of about touching upon how basic applied R&D fits in, how do you do commercialization, funding, government norms. You touched about some of the pooling of resources across, maybe this could be like pooling of state-of-the-art facilities, how we are bringing together all industry, academia, one can use others' resources, overall common user facilities. So with this, I think we have touched a bit about just touching upon that funding part, incentives part, how do we go the academia linkages, what can we do on the policy part. I think now it's very important to now think about R&D person, R&D talent in general, because when you're talking about, okay, systems are there, ecosystem is there, policy is there, but what is there for the individual, for the R&D scientist? What kind of talent, skills? How do we actually make that talent which comes from the grassroots of India, has the necessary skills, how we can augment it? And with this note, I would request Dr. Khan to share his thoughts.
Hi. So just, I just want to also, as I am representing CSIR, so I just want to let you all know that actually CSIR started one initiative called 1 Week, 1 Lab. So it's basically CSIR is a conglomerate of 37 labs with different expertise. And so we started one called 1 Week, 1 Lab. So it's basically one lab showcase all their achievements or what are the facility or the technologies they have to the industry. So it's basically meeting between the CSIR labs with the industry, and basically we asked the industry to come there, and we showcase their industry and ask what industry basically require from us on that one. Just to say in that one, so I mean, we all know petrochemical, all the refinery sector is moving towards totally new direction. It's a fast changing sector. And the main driver for any change or any innovation is basically two things. One is government or international regulations, and another is the change in the societal behavior. And what we are seeing in refinery or the petrochemical sector is basically now with the new climate change and other thing, we are moving towards more low carbon energy sources. So it can be renewable energy in form of like biodiesel or sustainable aviation fuel or hydrogen or some CO2 conversion fuel to other thing. Or basically because of societal change, we are going towards the CCT scheme, so the carbon capping and trading scheme. So those from moving from PAT to CAT scheme, so we are moving toward most sustainable environment. And all refinery and the petrochemical sector are also moving towards those direction. So all petrochemical upstream sector is basically they are downsizing, and most of the downstream is up because we are moving towards the crude to chemical, I think, all of the Indian petrochemical. And I think the R&D can play a big role on that one, providing new technologies for the crude to chemical processes, and also towards the new renewable energy sources like sustainable aviation fuel, the biodiesel, or any other, like you know that we are now mixing ethanol to the petrol. So basically provide new technologies for petroleum, ethanol production. So those things, I think, as a CSIR lab, with a lot of expertise in working with the petrochemical sector. So I am from CSIR IIP, so Indian Institute of Petroleum, and there is a say that there is no refinery in India which doesn't have at least one technology, product or process which is provided by IIP. So IIP has in long time has worked with the refineries, and I think we can work. But as I think Punitji told, so it's a very fast moving sector. And in a fast moving sector, we need skilled human resource. Because if it is a fast moving sector, there should be someone at the helm who can take, who can notice what are the opportunities in there. Because it's a process of taking opportunity where you put your money. Because if you put your money in a wrong horse, you will lose the bet. So you have to see what are the fast moving market where you can basically, what is your resources you have. So it resources both in terms of human resources and also the material or the raw material available. And then basically you can see what the products you can make, and you can make money. And basically the person who is in him, he can take decision on his own. So it's not had to be the management who has to give him a decision like you take, go to that product or that thing. And it should be fast. So he cannot like train someone for 2 years and then we asked him to do certain things, but it should be that on the fast go, he started giving some output. So that's why basically skilled manpower is very important for, at least for the petrochemical sector, because in 5 years, what we are seeing now, in 5 years or 10 years down the line, we'll see totally different petrochemical. It will be, it will be low carbon petro refinery with coupled with maybe biorefinery, coupled with it. So we have to have diverse knowledge section. It cannot be like only chemical engineering. We may need some biochemical engineering, or as it seems in the data science is coming in a long way. So we have to have some expertise in data science. So we know digital twinning and others, so is coming in the machine learning tools. So all those expertise had to be compiled together to go to the next generation biorefinery or the existing refinery to say. In that way, I just want to give the things back to Puneet.
Thank you, Dr. Khan. Just to summarize, I think how do you look at R&D talent, and I think you added a layer about material, that it's, and also that petrochemical today, specifically from R&D perspective, R&D doesn't look for petrochemical today, it looks for petrochemical tomorrow. And petrochemical tomorrow are fast changing. So the skill set of the manpower, the people also needs to evolve. We have to invest heavily in that, those exchange collaborations which we talked about, data sciences, technology, everything. In fact, when we look at expertise, we need not look at expertise simply in terms of one singular skill, but look at diverse skill of expertise which needs to come together to carry that R&D forward. with this note, actually, I would like to call Dr. Naik, and I would like to ask him about collaboration. We have, of course, collaboration is very important because it helps us to grow ourselves, not just within our shell, but beyond. So how does Dr. Naik, you see that R&D can foster collaboration? What could be done?
Hello. Thank you. India is, as we know that we are planning for the self-reliance India. And in India, if you consider, there are several universities, several institutes, R&D organizations, CSIR organization, NICERS, IITs, lot of institutions, young minds, experienced person, lot of brilliant minds are available in India. But even though this condition, we are importing huge amount of chemicals, starting material from various countries. So the issue comes that why we are unable to produce all these chemicals or maybe a starting material or anything. So issue, what I feel is that in India, there is we need a platform where one can share the problem. Identification of problem is a major issue in many of the university, many of the institutions, and many of IITs or wherever. So it is because of there is a single platform where it's not available, one can share their problem or another person can work on that problem. And second is, our colleague as is told, there are several basic research or maybe applied research, they are ending with just a publication or a patent. He can just publish, he will close the project, and he will apply for the next project, where we are struggling to implement the project or to come up with some startups or come up with a good collaboration with industries. And only platform what scientists do is, if he gets some idea, he approaches the industry, he talks with the industry, and he requests for the collaboration. And sometimes collaboration goes well, sometimes collaboration goes well, and depends on the money and project money and everything. So what I feel is, again, we need a robust system, a digital platform, or a platform where one can connect with each other, institute and also the R&D, or maybe industries, where one can share the problem, one can collaborate with each other, and they can work together. Then only we can able to produce or come up with some good idea so that we can go for the self-reliance India. That's one thing. And second is, in any research and development work, the work involves this supply chain. As we know that feedstock availability, most of the time, any R&D scientist or maybe research worker, they are not knowing that where to get a feedstock. If you get a feedstock, that's useful to go for the further implementation. What's the cost of the feedstock, whether it's a good feedstock or a bad feedstock, or even after collecting that one, he will do some optimization process, development process, and now the next he will go for the implementation. And many times we won't think for the carbon footprint, or maybe what to do with the waste generation or generated waste, where we can utilize or reutilize. All this comes with the supply chain and utilization process, where only collaboration and discussion or maybe some digital platform can bring a solution. Otherwise, it is very difficult to complete the entire chain or circular economy. Otherwise, I can say circular chemistry, it's very difficult to achieve. So in overall, I can say, the R&D, for example, our CSIR only, we have a lot of research work and development we publish or we showcase in our website. Many times the other organization or other R&Ds, they won't visit even to check what is available or what is not available. I feel that more showcasing is required and digital platform is required. Thank you.
Thank you, Dr. Naik. I think just to summarize what you touched upon, very, very essential, a digital platform where all the R&D houses, all the R&D people can correlate what is happening where, which asset is available. And the second thing which you touched about is collaborative ecosystem has startups, and need to have startups. How do you bring in to do some of your pieces? How can you actually make that R&D faster? And then the important thing which you linked up, that like today we are talking about emission management, what's happening in emissions everywhere. We're talking about carbon footprint. somewhere similarly on the R&D side, if we can create a similar narrative to bring out this collaboration model, something which we are seeing very closely in carbon sector, would be very helpful. I think with this, we have done a circle of our discussions, and now I think there are some very insightful questions which are opening up in my mind, and I just wanted to start again with Dr. Krishnan. And Dr. Krishnan, in fact, you heard all the 5 speakers, and in fact, various thoughts, various inputs, but when we link it back, the prima facie, when I see the problem which was stated somewhere between, that we are importing so many chemicals, and of course the answer is that how do we produce more and more indigenous chemicals? So how do you see what should be done to improve that indigenous R&D?
One has to go for a PPP mode. Unless you do the PPP mode, whatever the technology you develop, it won't get commercialized. And also once if you have a private partner, they will see that how that can be, make it economically viable, make it economically feasible. And then if you see that the plastic park, which was established in the year 2013, and today 10 plastic parks have been established. Initially, if you see that there were a lot of problems, especially in Paradip. Paradip, nobody was there to come for plastic park. Then what happened that the government took initiative, and morning also one speaker pointed out, they reduced the land cost. Then afterwards, now the industries have come and they have started establishing in the Paradip. That is one thing. And apart from the land cost, if an industry has to survive, then they need a common facility center. And the CIPET is providing a common facility center, both in Paradip Plastic Park as well as Tamod Plastic Park, so that all the industries which are coming up in the plastic park, no need to establish their own testing centers, or if they want to make small molds, dyes, or if they want to process something, or they want to do in-house recycling, they can make use of these CIPET facilities. That's what this thing. And if they need a manpower also, we are doing skill training also. CIPET is known for skill training, and we provide skill training, and then we are giving to the industries, so that we want to make the industries much more prosperous, as much more feasible. And apart from that, the DST is also providing one scheme known as SATI, Sophisticated Analytical Testing for the Higher Institutes, wherein the industry has to get participated, and then institute has to be there, and even startups, entrepreneurs, they have to be there, and they all work with a common theme, and everyone puts their own ideas, their own expertise, and then they make it the things successful. And the main requirement for that scheme is that after 4 years, it has to be sustainable. It is not that one-time investment, you invest and you do something, then afterwards you wind up as told by the previous speakers. It's not that. The SATI proposal is that you have to run a self-sustaining mode. Therefore, and then that cannot be done by a single individuals. You need expertise from industries, institutes, entrepreneurs, startups. All this is needed, and that they doing it. And CIPET, we are also established Innovex labs. In both places we have done it, one in Bhubaneswar and in one in Chennai, where we encourage the startups. They make use of our office facilities as well as our R&D facilities. They work on that, and then we help them also. Therefore, unless you have a PPP mode, unless you will not be successful, and they will not make it a commercially viable.
Thank you, Dr. Krishnan. In fact, some of these examples we talked about Paradeep, and of course we know who is providing the anchor load in Paradeep. And with this, I would like to go back to Gurmeet. Gurmeet, IOCL, you're part of IOCL, and IOCL has done some fantastic work with indigenization of refinery technologies. So there are some good learnings for petrochemical industry also to imbibe. So what are your thoughts and reflections on those?
In refining industry, IOCL is now an established name. The Intermax plant, which is running at Paradeep, is based on entirely on technology developed by IOCL R&D. and that plant is of 4.2 mmtpa, which is a significant amount, and that is feeding the output from that plant is feeding our PP and P units, downstream PPP units. So now if we talk about the petrochemicals, so that technology was example where we are generating feed for our petrochemical units through the development of indigenous technologies. Now we are also working on development of several niche technologies or the products which have been primarily imported in India. And one of example I will like to share with you is that this is Mantos wrapper, and it is made up of polypropylene, and the molecular weight of this polymer is around 2 lakhs. We developed an ultra high molecular weight polymer with molecular weight which exceeded 20 millions or 2 crores. So we made up a quantum jump from polymer from molecular weight of 2 lakhs to a polymer with having a molecular weight of 2 crores plus. We developed that product and then we translated it into a useful application for as drag reducing agent for our pipeline operations. And that was tremendously successful. We undertook a huge number of trials, and then we have to commercialize it on a faster basis. And as we have been discussing, collaboration is a very important factor, and it's a cornerstone for a quicker implementation. Then we identified a partner and we commercialized that technology with that partner in 2021. And by 2021 end, the production of that product started. 2022, we captured the 100% Indian market. A product which was getting imported into India in early 2021 at the tune of more than 2000 KL. By mid of 2022, we have replaced the complete imported product by our indigenous product. And that is because a company has got confidence on its own R&D, the developed product, and also we bet heavily on that collaboration, but that paid us off. From 100% imported to 100% indigenous product, drag reducing agent in India, HPCL, BPCL, HMEL, pipeline, everybody is using, all the pipeline operators are using product which was designed by my team members. So this is a way we can progress very quickly, very fast. We can go from conceptualization to trials to commercialization through collaboration. So it gives us huge impetus.
Thank you, Gurmeet. I think you have aptly put it out that defining the business case very clearly once the research was established, and then going into collaboration, partners, commercialization, step by step, everything done purpose-driven. But of course, since we are talking about R&D and innovation, and of course somewhere in between, in the starting, we said that let's focus more on applied R&D. But there is always the other side of R&D, which is basic R&D. And I think I would like to ask Dr. Ganesh about his views that basic R&D versus applied R&D debate. How should we actually divide a fine line? That what we should do more and who should do more and at what level? What could be the differentiation could be there?
Okay. Okay, but I'll answer this question, coming to this question. Before that, what in India, most of the time, the marketing or sales of the product depends upon the quality. Where quality can be achieved, again, along with the quality, the cost of the product is also required. And in most of the time, most of the seller, in most of the marketing issue in India is that they want to sell a product and they are not looking for the quality in most of the time. So this will a short-term or sales can happen, but if you see in a long-term goal, we are again coming back to the original level where we are unable to compete with the international level. So what we feel is we have a lot of innovations in India. Those are stuck somewhere, they are not implementing or not implemented properly. We are not coming to bring it to the industry, or we are not bring it to the sales or into the market. So those already developed things, we should be either it should be optimized and should be implemented. They are either with a startup or maybe with the industry collaboration. Those should be being pushed into the market, and we can fill some of the importing gap of our country. And second is R&D always requires a time. and also it requires some money. There's a lot of failures and lot of success also there, where failure, apart from failure, if out of 100 failures, if you are able to get success, even if the 10 product, that should 10 product can really reflect into the economy of India. So we should work on that prospectus. And third is the focused based research, where what country needs actually, we should focus on that particular part. It may be a active pharmaceutical ingredient, or maybe a polymer feedstock, or it may be any chemicals. And considering that, again I am saying the same thing, that considering we should, I also work not only our development, you should work on the carbon footprint, because India is strongly working on that area, and also the utilization of the waste, and moreover you should work on the circular economy first of all. Then only we can complete the gaps, or we can compete with the international level. And third, that this is expertise. When the question comes of expertise, we have a lot of expertises, and but most of the expertise are the very field specific. And if they are not having a real expertise with the other area, you should go and you should collaborate, you should talk, and you have to modify or implement the process. Then only we can grow faster and accelerate the R&D research, and also we can implement it in India. So thank you, sir.
Thank you, Ganesh. I think what you said, of course, applied R&D, basic R&D, what is there near, define, basic. Let's prioritize and do as per the plan, whatever the country's priorities are. But again, actually just building onto this thought and building onto the discussion which we have been having so far, I think thinking more and aloud on this, collaboration is something which is coming up as a strong theme. And I've taken a couple of inputs so far, but again, I would like to take input from Dr. Kamble on this, what he's doing differently at NCL, or what he thinks could be done better.
Just I will brief about NCL. Basically, NCL, we are doing basic as well as applied research, and we have very good, strong collaboration with industry. Our maybe you can say 50% scientists they are working basic work, maybe proof of concept or new idea, and 50% scientists they are working on applied, maybe development of process and product. So this approach we are working, and we have like a mixed project. Some project we have only for basic research from DBT, DST, government agency, and 50% project from industry, where we have to do work from maybe starting from literature, concept to commercialization. So such project may be required 5 to 3 years, minimum time maybe 3 to 5 years. Basic research maybe depends upon 1 or 2 years. Now I'm giving some example. Presently, my group, we are working on depollution of plastic. As you know that plastic waste is a huge problem. Everybody is talking about without plastic, no life is there. That is true. But how to deal the plastic waste? Because conventional technology, whatever the incineration or maybe pyrolysis, which is not sufficient because there is a loss of carbon and again pollution is there. So NCL, what we are trying to first separate the plastic. Basic is a problem that if you visit any MRF, that is material resource facility, where they are collecting all the material, whatever the waste material, it contains different type of plastic, polypropylene, polyethylene, then PVC, then PET, all types of plastic. So if you treat all the plastic together, then it is difficult and will not get appropriate result, and you cannot solve the problem. So NCL, our approach is to first to segregate the plastic. So there are a couple of techniques available based upon the density, flotation technique, or maybe solubilization technique, chemical solubilization technique, or other. So what we are doing here, we want to separate the plastic based upon their solubility. So we have generated huge data on separation of, maybe suppose we have mixed layer plastic, PP and PET. So how to separate first these two plastic, and subsequently we can do the polymerization. So initially we have developed that concept, so we have mixture, we can separate individual plastic. Once we have got that individual plastic, and how to do the depolymerization. So again, depollution, there are various techniques available, and in that we have also developed our own methodology. Suppose you take only PET, So PET already market technology available, but sustainability, whether it is eco-friendly, what is the cost of the final that product or process, that is most important. So in NCL, what we have done, we have developed process in such a way that whatever the chemicals we are produce, which has good value, and whatever the reagent or catalyst we are using, we should recycle multiple time, and we have scaled up the process. Maybe up to pilot scale, and we are on the complete material balance. Finally, industry want end-to-end solution, and now we have given this patent already filed, and presently we have given this process to industry, and they are in the phase of to commercialize the process. Similarly, in another plastic. So individual plastic, if you do the polymerization, it is possible. Like condensation polymerization, we have another concept, and additional polymerization, we have another concept. Because PET, polycarbonate depolymerization is very easy. But if you take PP, PE or polyvinyl chloride, we should have a different concept, because it is not so easy to depolymerize such kind of plastic. So we are working on advanced technique so that I'll get propylene or maybe ethylene as a product, then it is a value addition. So presently we are working on that direction. And another example is that presently we are using, we have another project from petrochemical industry where we are using C7 fraction, okay, for the production of IBB. IBB is important intermediate for ibuprofen. So if you use propylene and toluene properly, and if you develop a continuous process for the manufacture of IBB, then it will be real value addition. So initially we have taken as a proof of concept. After that we have developed a lab scale process. We have demonstrated to industry, and after subsequently we have a pilot plant project which is running. Its capacity around 25 kg per hour. So all design aspect we have completed. Now commercial pilot plant will come very soon in that industry premises. So basically our intention is to give end-to-end solution so that industry should get benefit. And as a R&D research organization, we are getting patent as well as ECF through industry. So similarly, we are planning to take a couple of projects from other industry, like we are thinking to produce salicylic acid, para-aminophenol, which is raw material for paracetamol. So such kind of some product we have already planned, and we are in the process to go ahead. Thank you.
Thank you, Dr. Kamble. You aptly put it out that collaboration and of course all these R&D topics at your level, at your organization level, it's good to take projects from various parts of the spectrum, and it helps you to reach out and solve those business problems, do those individual contributions.